Is copying a lot of files bad for the CPU or computer in any way? I'm using my laptop to copy a couple of hard drives to other hard drives. My laptop will probably be crunching through 20 in NBSB, TB of data. I'm wondering if this will affect my CPU long term in any way. And what if I did 1 in NBSB, TB at a time, and let the computer idle a bit instead of constantly copying for a day non-stop? I have an Intel Core in NBSB, i7 10750 hours, averaging 4.2 in NBSB, GHz. I also wonder if long-term effects depend on the CPU. FYI, all hard drives are HDD. Would the same answer be for SSD copying? Summary. Does copying a lot affect the CPU in any negative way, if you are copying HDD or SSD? Could the answer to one depend on the CPU? Would idling the computer between the job at intervals help if there are in fact bad effects?
Damage to CPU minimal, if any. 1a. CPUs are not heavily involved in file copies. The CPU's job is to tell the other hardware to do the transfer, and the actual transfer of ones and zeros is left to other chipsets/IOS to do. 1b. Even if a file transfer did use a lot of CPU, CPUs have incredibly good longevity and usually processors don't fail or go bad. They do get replaced regularly due to being outdated, which speaks to the fact of its longevity. A CPU will outlive its efficiency lifespan. Damage to HDD, still minimal, but worth considering. Using an HDD wears an HDD. It has moving parts, so the more they're used, the more potential for damage from wear, but if you can't use it, it's useless anyway. The best practice for HDDs is to know that at some point, it will fail and to have backups. This is the only real protection you have against HDD failure, backups. You can reduce the wear and tear on the HDD by ensuring that you run a single copy command at any given time, which is what I suspect is the typical method, so whether you do a drag and amp, drop or run a command like robocopy, make sure you only do one of these actions and let it complete before starting another one. Your specific questions. No, you will not affect your CPU in a negative way. In fact, you can open Task Manager during this and probably witness your CPU not go over 20% usage, depending on what else your computer is doing in the background. No, all CPUs are built to be robust. A 3rd Gen i7 versus an 8th Gen i9, or a Ryzen 7, what have you, is engineered to last and endure utilization far above what a file transfer will do to it. No, this would not be a helpful method to reduce the damage that we've already stated is negligible. Even if your CPU isn't properly cooled, this low utilization should not make it overheat, and if it does, its performance will only be affected while it's too hot. Its lifetime performance/longevity will not be affected by overheating.
No, for 2 main reasons. Intel and AMD custom desktop and laptop computers, if properly installed, cooled, not overclocked, and not subject to electrical problems like a bad power supply, will last a very long time even if all cores are constantly 100% utilized such that you don't usually have to worry about wearing out your CPU. Furthermore, even from the first PCs of the early 80s, disk drives used something called direct memory access, DMA. Floppy drives have used DMA since the first PC, and hard drives started to have DMA modes probably sometime in the late 80s. DMA basically allows drives to transfer data to and from RAM without the CPU in the middle. So hard drive transfers have even less of a CPU impact than you might think. Where the CPU might still be in the middle is if you have disk encryption running on your system, such as BitLocker, TrueCrypt/VeriCrypt, or other. But it's still not going to be anything to worry about. You are causing an HDD hard drive, not an SSD, to work harder by copying from it constantly. You're adding wear to an SSD by copying to it. Spinning Rust HDDs and even SSDs do have a finite lifetime that is likely less than your CPU. TL, Doctor, you should be much more worried about the lifetime of your drives, and have backups/multiple copies, than the CPU.
Most hard disks are rated for a few terabytes read/write per day for several years. Copying 20 TB once will use up a few days of the disk's lifetime, which is counted in years, usually 5 to 10 years. You may assure yourself that this is true for your disks by consulting the manufacturer's specifications. As regarding the CPU, such an operation will not use it at all. The CPU will most of the time be waiting upon the disks, so will not even warm up noticeably. So don't worry and go ahead. If something fails during the operation, this only means that the component was already in bad shape and would have failed anyway in a few days' time.
The answers stating that the risk is basically 0% are completely correct. However, I would add one thing too. Would the same answer be for SSD copying? As said in the top answer, both HDDs and SSDs do have a very much more relevant wear-induced failure risk than CPUs do. The failure modes are quite different. HDDs wear out from changing position. This happens on both read and write operations, but is minimized by changing large amounts of data in one uninterrupted batch. So, copying the entire contents is about the most wear-friendly way you can access a HDD. SSDs, flash-based ones, that is, don't care about reads, whether sequential or random access, but wear out from write operations, and that at a somewhat constant rate. You'll find very different figures about how many write cycles a flash cell can endure, ranging from 100 to 1 million. Also, the actual failures are stochastic, meaning some bits can fail quite quickly while most of the rest are still good. As a result, in particular cheap SD cards have a tendency to fail quickly, often being written only a couple of times. Decent SSDs will have error detection and block remapping algorithms that can avoid any catastrophic failure for a very long time, but it is still limited, in particular if you're going to write over and over and over again. The conclusion is that what you should not do is to copy data from a HDD to another by first copying part of it onto a flash storage, then to the target HDD, then next part to the flash and so on. Like, for example, if you have only one USB port and connect HDD A, copy to laptop, connect an amp, copy to HDD B, connect again A. Practically speaking, even this would only matter if you either have a truly huge amount of data, petabytes, or use an underpowered flash medium as the intermediate storage. If you would need to copy with intermediate storage, a HDD would be the better choice for that, because batch copying is what it's best at.
If you want to support the channel, please consider subscribing.